Extraction of aluminium is the topic for today's video. This is just an example of electrolysis, but there's some key features in this industrial process that we're going to go through in this video. This is what the setup looks for extracting aluminium in industry. Now, it may look a bit overwhelming, but actually it's just like every other electrolysis example that you've done. Let's label the key features. So what you've got here is a big steel case that everything is enclosed within because it gets to really high temperatures. The lining inside of that is made of graphite and makes up your cathode, so the negatively charged part of your electrolytic cell. So that is your negative cathode around the outside. The anode are these bits that come in at the top, and that's the positively charged part of your electrolysis. So you've got the positive in at the top and the negative around the outside. So they're still the same things there, they're just in slightly different places than they were before. In terms of the electrolyte in this case is purified aluminium oxide that is dissolved in cryolite. And we'll talk more about why it's dissolved in cryolite in the next part of this video. So, in terms of in that electrolyte, the ions that are present are the aluminium 3+ and the oxygen 2-. So let's check out what happens to those as they go through the electrolysis process. So what you'll have is the Al3+ being attracted to the negative cathode and the O2- being attracted up to the positive anode. Let's write half equations for what happens in each of those processes. So the cathode is the Al3+, which is in a liquid state. Now because this is really hot, when it becomes aluminium metal, that's also going to be in a liquid state when it's formed. To balance out the charges, I need to add 3 electrons on the left-hand side, and that balances out perfectly. The liquid aluminium comes off through this hole in the bottom of my setup here, and you get pure aluminium being tapped off there, which is really cool. Now, the anode is the O2-. Now, this becomes oxygen gas, which the formula is O2. So to balance this out, I need to make sure I've got 2 oxygens on the left-hand side. And then to balance the charges, if I've got 2 O2-, that means I need 4 electrons on the right-hand side to balance out the charges there. So at those positive anodes, I would theoretically see oxygen gas being generated at that point. These are 2 of the key questions that you could be asked about this industrial process. Firstly, why do we dissolve the electrolyte in cryolite? Why don't I just use purified aluminium oxide? Surely that would work fine. Now, purified aluminium oxide has a melting point of over 2000 degrees centigrade. That is crazy hot and ridiculously expensive in terms of generation of that kind of heat energy. Now, if you add cryolite to it and you turn it into a mixture in the pot, the melting temperature goes down to about 900 degrees, which is far more reasonable. So if you add cryolite, it reduces the operating temperature and therefore makes it far cheaper for the process to happen. The second question is, why do you need to replace the anodes? Now, at the anodes, we talked about how oxygen is generated at those anodes, but what you might not have spotted is that the anodes were made of graphite, and graphite is carbon. Now, if we were talking in the previous question about how this machine is at about 900 degrees centigrade, that is really hot, and actually it's hot enough for the oxygen gas to react with the carbon in the electrode. So what happens is the carbon reacts with the oxygen to make CO2. So over a period of time, that means that those anodes will wear away a bit at a time. Now, obviously, it costs money to replace the anodes, but the main cost of this process is all about the energy that's required to get it to temperature and the electricity that has to be put into it for the electrolysis to happen. By comparison, replacing the anodes is actually pretty cheap overall. That's all for how we extract aluminium using electrolysis. You're better off just thinking about this as a case study of electrolysis rather than thinking about it as this entirely new process, which it isn't really. Use what you know already and you should be able to work out most of the key facts to do with this.